Assalamualaikum warahmatullahi wabarakatuh. Hi everyone. This time we will discuss about resonance of sound waves. Okay, firstly we have to know what the purpose or objective to learn this module. Number 1, to understand the phenomenon of resonant sound waves. Number 2, to determine the velocity of propagation sound in the air. And 3, to understand the effect of temperature change on the velocity of propagation sound. Secondly, we have to understand about the basic theory of resonance. Resonance is the vibrating phenomenon of an object caused by the impact of a vibrant object with the frequency equal to the source. What the meaning of equal to the source? Equal to the source is example if you have a sound source and it produces vibration, but the vibration spread to other thing, and automatically the vibration will spread to B has similar frequency to A as the vibration source. And resonance of sound waves in air tube, or known as organopipe, are joint pulsate air molecules with the same frequency from source of sound. Physically, this phenomenon can be seen with increasing loudness sources. For instance, if you have the sound source which has volume 50, but you can increase the volume to 100 by using this resonance, and we can prove this theory after this. Before we learn more about resonance, we have to know what the meaning of organopipe. Organopipe is like this picture. The shape is like tube, but on this practicum we use the type of closed organopipe. Why we use closed organopipe? Because we need water on this practicum to prove the resonance phenomenon easier, okay? And closed organopipe marked by this side is closed and the other side is open. Based on the theory that I have explained, the resonance in organopipe happen if the superposition result come reflection in the form of standing waves. The meaning of standing waves is when come waves and reflect waves at one point and bunch. The volume increase in the resonance phenomenon on the example that I have explained happen because of the superposition and standing waves. So look at this picture. First resonance happen when the wavelength equal to 1/4. And if we want to find the frequency, we can use this formula. L equal 1/4 lambda. L is the length of organopipe and the lambda is wavelength. And thirdly, we discuss about the tools. The tools need on this practicum are audio frequency generator or a plus speaker, resonance tube scale, water reservoir from plastic, and rubber hose. Audio frequency generator usually put on the top because we want to drain the wave into the resonance tube scale. And the reservoir from plastic, why we use these tools? Because we want to up and down the water surface in here. So the function of reservoir is to up and down the surface of the water, so that we can easily to find the standing waves and easy to hear the resonant sound. Okay, that's all. The basic theory of resonance waves. For more details, we discuss on the procedure and data processing.
Hello, Assalamualaikum warahmatullahi wabarakatuh. Right now, we're going to demonstrate what tools we're going to use in this sound wave resonance module. There are tools including 1. audio frequency generator, 2 speaker, 3 organopipe, 4 plastic water reservoir, and the last one, 5, is jumper cables. Okay, right now I'm going to explain in detail about this audio frequency generator. So first, there's the power button here. Obviously it is used to turn on or off the tool. Next, there's a section here that's used as an amplitude regulator. So if you all want to adjust how much the audio volume that comes out from the tool, you just set it up from here. Next, there's the frequency regulator section. So we can adjust how loud the sound that comes out from this tool by this frequency section. The last one, there's the cable input, which is used as a connector between the audio frequency generator itself and the speaker. Okay, so there are several components here. The first one is the speaker, which is used as an audio output from the audio frequency generator. Next, there is an organopipe, which is used as a wave propagation medium that has been produced from the speaker before. The last one, there's a plastic water reservoir. We use this water reservoir to raise and lower the water level contained in the organopipe, which is used as a reflective wall for the waves that have been produced before from the speaker itself. So as we can see here, the water level will rise along with the plastic water reservoir and vice versa. Therefore, the water level will always be parallel to the plastic water reservoir. Okay, next, I will explain how the practicum works. The first thing you have to do is to set up the audio frequency generator. As my previous explanation, there are two parts, which are the amplitude and the frequency regulator. All you have to do is to set up how big the amplitude and the frequency we want to produce. In the amplitude section, keep in mind that the audio volume produced by the amplitude regulator must not be too low or too high. Just keep it in the middle and sufficiently, or at least we can hear the audio volume. In my opinion, the exact amplitude value is 1.4 volt per bit. We can already hear the audio around that number. Next, you will need to adjust the frequency section by finding a frequency between 600 to 800 Hz. Later on, you will have to look for the differences between these three frequency values. Here, I will explain to you what's the difference between a resonating sound wave and one that is not. Now pay attention as I turn it on, okay? Here I will find the resonance point. Now, I just got one resonance point. Keep in mind, I will do this over and over again so that all of you can clearly hear the sound waves. Now, if you heard it at the moment, it's not a resonant sound wave. Still, it's just a normal sound wave. Let's take a look again. Here is normal too. There, right there, is the resonant sound wave. Did you get it? I'm going to repeat it so you can all hear it one more time. Over there, that's the resonant sound wave. Now, I will set up the resonance point. There. right here. This is the point where the sound wave resonates.
Oke, baik. Di sini kita akan melakukan praktikum yang pertama, yaitu untuk mencari di mana aja titik-titik resonansi untuk frekuensi 600 Hz. Oke. Untuk yang 600 Hz ini, saya akan bantu teman-teman mencari di mana aja titik resonansinya. Baik, saya lakukan aja. Tapi perlu dicatat, untuk resonansi frekuensi selanjutnya, teman-teman harus cari sendiri ya. Nah, langkah pertama kita buat permukaannya ke atas dulu. Oke, kita turunkan perlahan-lahan dan cari titik resonansinya. Baik, resonansi pertama itu 12 cm. Kita turunkan lagi, kita cari resonansi yang kedua. Resonansi yang kedua itu 41 cm. Resonansi yang ketiga 70 cm. Dan resonansi yang keempat 99 cm. Oke, itu data 4 buah titik resonansi 600 Hz dari atas ke bawah, dan kita akan melakukannya lagi dari bawah ke atas. Baik, kita mulai. Resonansi yang keempat 99 cm. Resonansi yang ketiga 70 cm. Resonansi yang kedua 41 cm. Resonansi yang pertama 12 cm. Oke, baik, di sini saya akan melakukan praktikum untuk yang 700 Hz. Nah, teman-teman semua harus memperhatikan dengan seksama ya, karena di sini saya akan melakukannya hanya sekali percobaan, dari atas ke bawah sekali dan dari bawah ke atas sekali. Oke. Nah, yang perlu diperhatikan, apabila yang 600 Hz tadi saya benar-benar tuntun teman-teman sampai ke titik-titik resonansinya. Nah, di sini nantinya teman-teman harus menentukan sendiri. Tapi masih saya bantu, yaitu ketika terjadi titik resonansi, saya akan bilang resonansi. Oke, paham? Langsung aja, kita mulai yang 700 Hz. Kita mulai dari paling atas ya. Oke, baik. Saya akan mulai turunkan. Resonansi. 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 Oke, itu udah terjadi 4 buah titik resonansi. Kali ini saya akan melakukan percobaan ini dari bawah ke atas, dan teman-teman perhatikan lagi ya, di mana titik-titik resonansinya. resonansi, 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 resonansi. Oke, baik, di sini kita akan memasuki praktikum selanjutnya, yaitu untuk yang 800 Hz. Nah, kali ini teman-teman harus benar-benar menentukan sendiri di mana titik-titik resonansinya. Saya tidak akan tuntun teman-teman semua, jadi teman-teman harus perhatikan dengan baik ya. Dan ini percobaannya dilakukan hanya sekali. Kita turunkan sekali dan kita naikkan sekali. Oke, harap diperhatikan. Oke, saya mulai dari atas. Oke, kita turunkan secara perlahan. Oke, tadi sudah terjadi 4 buah titik resonansi ya. Saya harap teman-teman udah dapat ya titik-titik di mana aja. Oke, untuk meyakinkan titik-titik itu, saya akan lakukan sekali lagi dari bawah ke atas. Perhatikan ya.
Okay, thus we have finished running the resonant sound wave practicum. Later on, you all have to process the data that you got earlier and make sure you can guess how much is the airspeed in this room. So, have a good time doing it, okay?